अक्षता, आनंद, अंजुम.
Present, sir.
ओके. बसवराज, गडकरी, बसवराज ऐनापुरे, भाग्यश्री, भक्ति, भक्ति, भारती, चेतन कुमार, चेतन कुमार, दीपक, दिव्या, गढ़ प्रथमेश शिवाजी, ज्योति.
Present, sir.
ओके. किरण, लक्ष्मीकांत, मानतेश.
Yes, sir.
ओके. मोळे प्रेम, नागेश, नंदीश.
Present, sir.
ओके. पूजा.
Present, sir.
ओके. प्रमोद कुमार, प्रवीण, प्रियंका, संध्या, संतोष पुजारी, संतोष सोनार, शाहबाज.
Present, sir.
राइट. शफिया.
Present, sir.
राइट. श्रीधर, सृष्टि,
Present, sir.
सिद्धार्थ. ओके. सिद्धार्थ वर्णेकर, सिद्धार्थ पाटिल, सुप्रिया.
Present, sir.
राइट. वंदना, वसंत, वेदत्ता, योगेश,
Yes,
महेश.
sir.
ओके. महेश, बाळेश, तैक मोहम्मद.
Yes, sir.
ओके. प्रवीण राठोड, अभिषेक, ऐश्वर्या.
Present, sir.
ओके. अमानुल्ला, बंडोडकर तनय मोहनदास, भावराव, शोधन, देवानर अनिल कुमार शेकप्पा, नंद कुमार, प्रमोद, रोहिणी, रोहित, शशिधर,
Attendance code.
शशिधर, श्रीधर, श्रीधर, स्नेहल, वैष्णवी, साइश, कार्तिक. ओके. Anybody else? Right.
Sir, Bhakti Bastwadkar present.
I have marked yours. Anybody else? Okay. In the last class, I was discussing about the programs. You are able to see the screen? Are you able to see the screen?
Yes, sir.
Yes, sir.
Okay. So the program is write an 8051C program to calculate the checksum byte for the data given in above example. So in the above example, the previous example, we calculated the checksum byte. What is checksum byte? Checksum is we are adding the data, that is the given values 25H, 62H, 3FH and 52H, whatever values are given. We add them, discard the carry After discarding the carry, whatever value remains, we are taking the 2's complement of that value, right? That will be nothing but the checksum byte. Once we get the checksum byte, we have to perform the checksum operation to ensure that the data is correct. Whatever data values are there, they are correct. They are not corrupted. To ensure that what we are doing, we are adding the data values along with the checksum byte. Once we add these data values 25, 62, 3F, 52, suppose say we are getting the checksum byte as E8. We add these values along with the E8. Once we add them, so there will be 5 values along with these 4 values. One more is the checksum byte. Total there will be 5 values. When we add them, then the total sum will be 0. Total sum should become 0. It means that the values whatever are there, they are not corrupted. Suppose if one of these value changes, suppose instead of 62, second value it becomes 22H. Then after we add these values along with the checksum byte, then the value of the result will not be 0, 0. If some value is corrupted, if some value changes, then the value is changing. Because of that, the checksum final answer that will not be 0, 0, it will be some value. This indicates that some of the value is changed or some of the value has been corrupted. That was what we performed in the last class, right? And we also illustrated the checksum operation considering the checksum byte, and we showed how it detects the error. In continuation with that, next one is to calculate the checksum byte for the data given in above example. We have to write a 8051C program. Let us write a 8051C program to calculate the checksum byte for the above example. So what all we did manually, we have to put it in the form of C statements, C language statements to get the program. The first statement always begins with the hash include reg51.h, hash include reg51.h, reg51.h, then void main, void main, right? It does not return any value, so it should be declared as void. Then we are initializing the variables unsigned. We have to define the loop index. We have to consider the array with the values, that is what all values are given, that is say 25, 62, 3F and 52. We have to consider these values. So what I'm doing, unsigned character, my data of the array that is equal to, what are the values? The values are 0x25, then 0x62, then we have 0x3f, then 0x52. These are the values. Okay. Once we and declare them as the array here, unsigned character my data. Then next is we have to define the loop index and we have to initialize the sum. Like how we write in C language, sum is equal to sum plus. First we initialize sum equal to 0. Then we write sum is equal to sum plus data. Right. Similarly, here we have to initialize the sum variable. Right, or the my data, we are adding the initializing sum equal to 0 first, then we are adding sum is equal to sum plus my data of x, right? So for that sake, we are initializing unsigned character sum is equal to 0. Then next is we have to define the loop index, right? Loop index unsigned character x, unsigned character x. Next is the checksum byte, whatever we are getting after addition of the given values, right? We have to take the addition of these values, get the 2's complement, add these values, discard the carry, whatever value remains, that value we have to take the 2's complement. That will give the checksum byte. Unsigned character, unsigned character, checksum byte, some byte. Next is we have to define the array. Define the array for x is equal to 0. X is equal to 0. How many values are there? There are 4 values. X less than 4 because it is 0 to 3. X less than 4. X plus 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 plus. Then inside the bracket we have to find the sum. Sum is equal to sum plus my data of x. That means initially say sum will be 0 plus my data of x equal to 0. My data of 0 will be 25. 0 plus 25 will be 25. Next time x will increment to 1. That is sum is equal to sum plus my data of 1, that is 25 plus my data of 1, first value, that is 62. Then next time whatever result is there, that will be stored in sum plus my data of 2, x will be 2. So second value is 3f. So 3f will be added to the previous value of the sum. So this will continue here up till it adds the last value, that is 0x52. Now what we can do is we can display whatever my data is there, these values we can display them on the port also. We can have an additional instruction for that sake. P2 is equal to my data of x. That means whatever is the value here we have taken 25, 62, 3 or 52. These values will be displayed on the second port P2, right? Just for observation purpose, for observing these values, we can store it or we can assign it to port P2. Next, whatever sum we are getting, that also we can see on some port. So I will assign P1 is equal to sum. P1 is equal to sum. That means whatever this sum we are getting, checksum byte, that we can see on the port P1. Okay. So this is how we are writing the main program. The next is we have to take, once we get this checksum byte, this sum whatever we are getting, we have to take the 2's complement of that. We have to take the 2's complement, that is checksum byte is equal to, what is the symbol for 1's complement? This is a symbol, 1's complement of sum plus 1, that will give us the 2's complement. We are getting 1's complement, we are adding 1 to that, then we'll get the 2's complement. 2's complement we are assigning it to checksum byte. Okay. Then this answer also we can see, we can observe on some of the port. The same whatever we are observing here on port P1, we can take the same port and observe the checksum byte. Okay. So this ends our program, which is to find the checksum byte with the given values. They will give us the values, or if they don't give the values, you can assume certain values, 4 values, any 4 random values, right? Then write a C program for the given values or for the considered values. Okay. This is how we are writing the 8051 C program. Okay. First we are initializing, first part is the initialization, that we are initializing the given values sum x, checksum byte. Then we are using the for statement. We are using the logic sum is equal to sum plus my data of x, that is the logic. And to find the 2's complement, whatever sum we have got here, the addition of these values by discarding the carry, actually it will take 8-bit only. Carry will be neglected by itself because the register can store maximum 8 bits, correct? Therefore it will discard the carry. Whatever value we are getting, first we are taking 1's complement, we are adding 1 to that, so that we get the checksum byte or the 2's complement of the whatever values we have added. Okay. So this is how we are supposed to write the 8051C program. Any doubts in this? Any doubts in this? Any doubts in this C program? Is this program clear here?
Yes, sir.
Okay. We'll move ahead with the next program. Write an 8051C program to perform step B of example 3. If data is good, send ASCII character G to P0, otherwise send B to P0. The example that we have taken, that is example 3. Okay. So it is nothing but the example that I explained in the previous class, this one. So perform the checksum operation to ensure data integrity. Okay. This is the part B of the example 3. Perform the checksum operation to ensure data integrity. 8051C program we are writing to perform this data checksum operation to ensure data integrity. If data is good after addition, if the data is not corrupted, we are sending the ASCII character G to P0, otherwise send ASCII character B to P0. For this we are supposed to write a 8051C program. It's a simple program. First again start with the header file, hash include reg51.h, hash include reg51.h. Okay. Then the main function, void main. Okay. Then coming to the main program, we have to define again the array. We have to again define the array to perform the checksum and then check the checksum value whether it is good or not. Okay. Unsigned character, my data, unsigned character my data of, okay, that will be, we have to consider the values 0x25, whatever values we have to consider previously, the same values 0x62, then 0x3f, then we have 0x52, 0x52, then the checksum byte, that is 0xE8, 0xE8. Okay, so these are the values. Okay, the first four values are the given values 25, 62, 3f and 52, and the last value is the checksum value, that is E8. Once we have defined them with the array, then next is we have to define the loop index and the checksum. Assigned checksum is equal to 0. First we are initializing unsigned checksum is equal to unsigned character, it is unsigned character checksum is equal to 0. Okay. Next define the loop index, unsigned character x, then write the for statement for x equal to 0, x less than, how many values are there? 5 values, x less than 5, because it will take from 0 to 4, x less than 5, x plus plus. Okay. Then if we have to perform the checksum, we have to add the values along with the checksum. Checksum is equal to checksum we have assigned it as 0 first, checksum plus my data of x my data of x. Okay, checksum is equal to to checksum plus my data of x. First time checksum is equal to 0, 0 plus my data of x, that is first value 0 plus 25, 25 will be stored in checksum. Second time 25 plus previous second value 62, my data of 1, 62, the result will be stored in checksum. Next time previous result plus third value, that is 3f, will be added, and next time 52 will be added. Like that it will add all the values up till E8 including E8, right? Now once we get this checksum value, the addition of all the values including the checksum, next we have to check for whether this value is 0 or not. That is our how the checksum operation we are performing here, is it not? The main checksum operation is we are adding the values along with the checksum byte. The result should be 0, then only the values are correct. If some value has changed, if they are corrupted, then we don't get the answer as 0. If checksum is equal to 0, so for comparison we have to use double equal to sign. For assigning we can use single, we are using single assign equal to symbol. Sum is equal to 0, then what we have to do, we have to send the character what they have mentioned, send G to P0, send G to P0. So P0 P0 is equal to G, 0 is equal to G, else 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 P0 equal to B, else P0 equal to B, not equal to B. If the data is good, if it is not corrupted, then we are sending the character G to P0. We are displaying G on P0. Otherwise, we are sending B. We are displaying B on P0. Okay. First end the for loop, then end the main program. So this is how we are performing the checksum operation, right, with the given values, and we are checking if the checksum is 0, then we are sending the character G, which is meant to indicate good to P0. Okay, if it is not good, then we are sending the character B to P0. Okay, G for good to P0, B for bad to P0. Okay, then here whether G will be displayed on P0. Actually, G will not be displayed on P0. The ASCII value of G will be displayed on P0. Okay. Suppose say the ASCII value of G is 47. Let us assume that 47H. Then 47H will be displayed on P0. That is 01000111. That will be displayed on port P0. Here also suppose say the ASCII value of B say 42H. Then 42, that is 010044. 2 is 0010. These values will be bits will be displayed on port P0, but not the character. Okay, these are the characters, but their ASCII values will be displayed on the port whatever we are using, but not the characters. Clear here? Even though we are sending these characters G and B, but their ASCII values will be considered and they will be observed on the port which we are using in the program. Okay. Is this program clear, students? This second program is clear here to perform the checksum operation. Is it clear here?
Yes, sir.
Okay. What about others? For others, is it clear or any doubts, any questions here on this program? Any questions? Sridhar, any questions?
No, sir.
Okay, right. Let us take up the third program. Write an 8051C program to convert FDH to decimal and display the digits on P0, P1 and P2. Write an 8051C program to convert FDH to decimal and display the digits on P0, P1 and P2. Okay. Here they are performing the conversion operation, that is conversion of the hexadecimal value to decimal value. Right? You may be familiar with this, how to convert the given hexadecimal value to decimal value. Let us look into that. We already taken up this in our previous classes, how to convert the hexadecimal value to decimal value. The same logic remains the same. Just we are writing the program for the C language using 8051 C language. We are writing the program for converting the given value which is in hexadecimal to decimal value. Okay. The logic of the program is, suppose what the value they have given, the value that they have given is FDH, FDX. This is the value that is given. Correct? FDH is F is 1111, then D is 1101, 1101. F is 1111, D is 1101. Okay, FDX. Now for this FD hex, how to convert it into decimal? If you want to convert this FDH to decimal, there's an algorithm here. Algorithm. We have to know this algorithm. According to this algorithm, we are dividing FDH first by the value 0A. This is divided by 0A. Once we divide FDH by 0A, what is the quotient that we are getting and the remainder. Keep your calc in hexadecimal mode. Okay, hex mode. Divide FD by 0A. Okay, we have already done this in the previous classes. Just it's a repetition of that quotient. We have to check for the quotient and the remainder. So the quotient that we will get is quotient that is 19. Quotient is 19, and remainder is you are getting the least significant digit. FD is how much in decimal? FDH is how much in decimal?
253. 253.
250. Exactly. 253. Now 253 divided by A, it is as good as doing 253 divided by 10. So 10 into 25 is 250. Remainder is 3. So same thing we'll get for the hexadecimal division also. Remainder is 3. Remainder is 3. Okay. Then once we perform this division, next is whatever quotient we are getting here, again that we are dividing by A or by 10. Now quotient is 19. This we are dividing by A again 0A. 0A. Once we divide this by 0A, the quotient that we are getting is 0A into 2, and remainder is the middle digit, that is 5. Middle digit. Okay, 25 is as good as, first we are doing 253 by 10, that is quotient is 25, remainder is 3. It is the least significant digit. So this is our least significant digit, LSD. LSD. Then 19 divided by A. 19 divided by A is 25 is the quotient that we have got previously. 25 divided by 10 is the quotient. Again 5 is the remainder. 10 to the 20. 5 is the remainder. This is the middle digit. Middle digit. Middle digit. The next one is we are performing 2 divided by A, 2 divided by 10, that is 2 on, that is we get 2 only. Correct? 2 divided by 10 is how much? 10 zeros are 0, we get 2 only. That is our last operation, or whatever quotient we have got here, that only we can take it as the most significant digit. MST, most significant digit. Quotient that is obtained here, that itself we can consider as the most significant digit. Okay. This is the logic of the program. This is the algorithm or the logic of the program. Whatever value is given, that value you have to divide by A or 10. You get some quotient, you get the remainder. The first remainder is the least significant digit. It's the least significant value. Then whatever quotient you are getting, again that it has to be divided by A or 10. We get some quotient and the remainder will be the middle digit. Then whatever quotient we are getting, that itself is the most significant digit. Okay. So the answer is 253. 253. This is the decimal equivalent of the given hexadecimal number FDH. Clear here? 253. This is the decimal equivalent. 253 is the decimal equivalent of the given hexadecimal number FDH. Okay. Now we'll write a program for this to convert the given hexadecimal number to decimal number. Start with the header file. Hash include reg51.h reg51.h main function void main. Okay. Once we have written the main function, inside the main function we have to initialize. Let us initialize the different variables that we are using in the program. Unsigned character x for the value that we are taking. Okay, value we are obtaining there, that we will I will explain there. Binary byte comma d1 comma d2 comma d3. Okay. Now what is a binary byte? Binary byte is the given value, that is bin byte, a given value that is 0xfd. They are given it as 0xfd. It is 0xfd. Correct? This is the given hexadecimal number or the binary number fd. Then next is we are writing the logic. X is equal to binary byte bin byte binary byte divided by 0a or okay. So even if you divide by 10, internally it will take it as divided by 0a only. Okay. So divided by 10, then this is we are dividing by 10. The next time what we are doing is, so here what we get, it is 253 divided by 10. What will be the quotient? Quotient will be 25 and remainder will be 3. Now tell me, binary byte divided by 10, whether quotient will be stored in x or remainder will be stored. Whether quotient will be stored in x or remainder will be stored in x.
Quotient.
Quotient will be stored because it's a division operator. Quotient will be stored in x, right? So 25 will be stored in x. Here we are getting x equal to 25. X equal to 25. Okay. Next, so we got 25. But what we have to get here, the least significant digit, that is 3. Now, if we want to get the least significant digit, then what we have to do? D1 is equal to D1 is equal to that is binary byte divided by instead of division we have to take the mod operator. Okay, I'll tell that binary byte mod operator. Now tell me what will be the remainder. What will be the value in D1? Yes, anybody? What will be the value in remainder? Binary byte is how much? 253.
Sir.
1 minute. 253. So 253 mod 10. Okay. What we will get? Yes, please. What is the function of mod operator? This is the mod operator. What we have used here is the modulo operator or the mod operator. What is the function of the mod operator? Can you all recollect? Mod operator always gives the remainder. This mod operator always gives the remainder. Therefore, binary byte is 253. Mod 10 means remainder is 3. Therefore, here we get 03. This is our least significant digit, LSB. So we got the least significant digit. Okay. Next, what if we do, we get the middle digit? Can you think of it? Here we have got it as 25, x equal to 25. Now, what we should do to this 25 to get 5? To get 5.
Divide by 5.
This is how much? 25. Okay, what if I do to this 25, whether I have to use division operator or mod operator, you tell me, then I will get 5 as the remainder, middle digit, 5, middle digit.
Mod,
What I
sir,
have,
mod.
mod operator, I have to use, exactly, mod operator should be
10.
used. Yes, D2 is equal to x mod, then x mod, how much? 10. So just let us check it. X is how much? 25 we have got here. 25 mod 25 mod 10. 10 to the 25. Sorry, 10 to the 20. 5 is the remainder. 5 is the remainder. We'll get 5. We got the middle digit. Right? Next, what if I do now? I will get the most significant digit, that is 2. What value I have to take and what operation I have to perform so that I will get the most significant digit, that you have to tell me. Here we are having 25. Now can we do something to this 25 value to get the most significant digit? Yes. Can we do something to this 25? Can we perform some operation on this 25, whether division or mod operator, and get 2 as the value? That is the most significant digit. Which operation should be performed? It is division operation, is it not? It is division operation. D3 is equal to, here we have already got x. X is 25. So it is x divided by 10. That is, this is nothing but x divided by 10 is nothing but x is 25. 25 divided by 10. Answer is 2 is the question. Correct? Now I got the most significant digit. This is the middle digit. Then later I have got the most significant digit. This is the most significant digit, MST. Okay. So you got all the three, that is the least significant digit is stored in D1, the middle digit is stored in D2, then the most significant digit is stored in D3, D2, D1. That will give the converted value of the given hexadecimal value FDH. Clear here? So this is how we have to perform the operation. If we want to observe these values, then we have to assign them to port. You can use any port, P0, P1, P2 or P3. Let us say we are using P0. P0 is equal to D1 for the port D1 value. And for next value, I am assigning it to P1, P2, D2. Then the third value, I am assigning it to P3. P3 is equal to D3. Okay. So this is how we are performing conversion of the given hexadecimal value to decimal value. So such examples may be asked in examination. But checksum is also one of the important example. Many times it has been asked in examination. Then they may ask how to perform the checksum. That is one program. The next program is how to perform the checksum operation. That is another program, right? To find the checksum byte is one. This is the first one. Then second one is how to perform the checksum operation. That is check whether the checksum is 0 or not 0. Okay. The second program, and the third one is the conversion, right? That is converting the given hexadecimal to decimal value. Okay. So is it clear here, students? You all understood these programs? Any difficulty here in these three programs? Just see if you have any questions or any difficulties, you can ask. This is the algorithm here for the third program. Remember this algorithm. Okay. If you remember this logic, this algorithm, you'll be able to easily write the program. Okay. So any questions here, students? You all understood here?
Yes, sir.
Okay. What about others? Have you all understood? Anjum? Have you understood Anjum? Bhakti? Bhakti? Jyoti? Jyoti? Mantesh?
Yes, sir. Understood.
Understood. Any problem in understanding, Mantesh?
No, sir.
Any questions?
No, sir.
Okay. Nandish? Nandish?
Yes, sir. Understood, sir.
Understood. Okay. Pooja? Pooja?
Yes, sir. Understood.
Clear with the today's programs, Pooja?
Yes, sir.
Concepts you all understood, logic of the programs?
Yes, sir.
Okay. Shabaz?
Yes, sir. Understood.
Understood. Any difficulty, Shabaz?
No, sir.
Okay. Shafia?
Yes, sir. Understood, sir.
Clear with the today's programs?
Yes, sir.
Okay. Shushti? Shushti?
Yes, sir. Understood, sir.
Okay. Supriya? Supriya?
Yes, sir. Understood.
Okay. Yogesh? Yogesh? Taik Mohammed?
Yes, sir. Understood.
Any doubts, Taik Mohammed?
No, sir. It is, sir.
You understood the programs? It is clear, right? All the three.
Yes, sir. Yes.
Okay, fine. Aishwarya? Aishwarya? Clear with the today's concept?
Yes, sir.
Okay.
Sir.
ಹೇಳಪ್ಪ ನಂದೀಶ್ ಹೇಳ್ರಿ.
ಸರ್ ಸ್ವಲ್ಪ ಜರ್ನಲ್ ಬರೀ ಸ್ವಲ್ಪ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಕೊಡ್ಬೇಕು.
ಹಾ ಕೊಡ್ತೇನ್ರಿ. ವಿಲ್ ಟೇಕ್ ಅಪ್ ಒನ್ ಸೆಷನ್ ದೇ ರೈಟ್. ಅದು ಹೇಳ್ತೇನ್ರಿ, ಒಂದ್ ಸೆಷನ್ ತಗೋಣ ಅಂತ. ನಾಳೆ ಅಥವಾ ನಾಡಿದ್ದು ಒಂದ್ ಸೆಷನ್ ತಗೋತೇನ್ರಿ. ತಗೊಂಡು ಅದ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ಡೀಟೇಲ್ ಆಗಿ. ಹೆಂಗ್ ಜರ್ನಲ್ ಬರಿಬೇಕು, ಏನ್ ಬರಿಬೇಕು, ಯಾವ ಪೇಜಸ್ ಯೂಸ್ ಮಾಡ್ಬೇಕು, ಸ್ವಲ್ಪ ಡೀಟೇಲ್ ಆಗಿ ಹೇಳ್ತೇನ್ರಿ. ಅದಕ್ಕೊಂದ್ ಸೆಷನ್ ತಗೊಳ್ಳೋಣ ಅಂತ ಲ್ಯಾಬಿಗೆ ಒಂದ್ ಸಪ್ರೇಟ್ ಆಗಿ. ನಾಳೆ ಅಥವಾ ನಾಡಿದ್ದು ತಗೋತೇನೆ. ನಮ್ಮ ಪ್ರಯರ್ ಆಗಿ ನಿಮ್ಗೆ ಇನ್ಫಾರ್ಮ್ ಮಾಡ್ತೇನೆ ಯಾವಾಗ ತಗೋತೇನೆ ಅಂತ ಹೇಳಿ. ಯೂಶಲಿ ಮಧ್ಯಾಹ್ನದಾಗ ತಗೊಳೋಣ್ರಿ. ಇನ್ಫಾರ್ಮ್ ಮಾಡ್ತೇನೆ ನಾನು ನಿಮ್ಗೆ. Okay. Anything else you want to ask? Any other doubts you are having? Sridhar? Any questions, Sridhar?
Sir, please take my attendance too, sir.
ಬರ್ಕೊಂಡೇನ್ರಿ ಶ್ರೀಧರ, ಅವಾಗ ಬರ್ಕೊಂಡೇನ್ ನಿಮ್ದು.
Okay, sir. Thank you, sir.
Okay, okay. Anybody else? Snehal? Any doubts? Snehal? Okay. Then in the next class, I'll be taking up, that is the other part of the module, accessing code ROM space in 8051C. We'll just take a theory on that. and then we'll continue with the some other programs like hex down counter and the other programs. Okay, that I will take up in the next class. Thank you.